Good morning, guys. Welcome to our first somewhat live post here on Emergency Survival Geeks. My name is Hannah. I'm a medical doctor, and I am one half of the business. My husband and I run Emergency Survival Geeks together. We are a preparedness and survival business located in northern Idaho, so we pretty much deal with anything from firearms training, defensive tactics, any type of bug out, or security consultations, and then, of course, also medical preparedness. So since that is my topic of specialty, I'm going to be talking to you about one topic in particular, radiation poisoning today. Also, just wanted to let you know I am still getting over a cold, so if I'm losing my voice along the way, please bear with me. It usually returns after a few minutes. And also wanted to apologize. This was originally supposed to air yesterday, but I was having issues trying to figure out how I can run a Facebook Live post while also recording my screen, because for this topic and some others that I have lined up, it would be really helpful if you could look at the images while you're also listening to me talk. So if anybody knows how to run that, please let me know. I would really appreciate it. So yeah, let's jump right into it. So one of the reasons why I wanted to choose radiation or radiation poisoning in particular as a topic today is simply because if you are my age or older, then you have probably heard of 2, if not 3, incidents related to nuclear accidents in our lifetime. The biggest one probably being Chernobyl in '86. Also, Fukushima in 2011 is still in the news pretty much weekly, it seems like now, almost 6 years later. And then probably the biggest accident as far as the U.S. is concerned, we had the 3 Mile Island accident in Pennsylvania in, I believe, '79. So it still can happen anywhere. That we run nuclear plants. I know here, if you're in the Pacific Northwest, there's a few that are active and also a few that are not currently active anymore that still present the potential of an accident happening, or of course also in any type of war or SHTF scenario. There's always talk about what could happen and what they would do. So I'm just mainly going to focus on the medical aspect of this topic, but we do have to dive into physics a little bit. So bear with me, and I hope you can recall your physics high school days a little bit. Just really quickly, so you can understand what radiation is. I always feel like if you don't understand what something does or why it does something, it's going to be hard to retain it. So radiation, there's 2 main categories. So we've got ionizing and non-ionizing radiation. Both kinds are all around us at any given point in time. So ionizing radiation is the type that we're using in my field quite a bit. So it is a type of radiation that carries energy, and then when those energized particles hit another particle that also carries a charge, that is what we're basically using when we're doing X-ray imaging, CT scans, anything like that. The exposure that is involved with that is very, very minimal. I'll get to the units a little bit later, just so you have a visual in front of you as well. But it is said that medical equipment, even let's say a CT tech that is around that all the time, only gets about 0.5 rems per year. I'll bring that back up when we're looking at the chart later, but that is very minimal. In comparison to that, if you have ever been on a long distance flight, I personally used to travel long distance all the time. So let's say a 14-hour flight, that could be New York to Tokyo or whatever destination you'd like to pick. One flight there and back is only about 1/4 the exposure of, let's say, a mammogram, for example. So not very high either. On the other hand, we have non-ionizing radiation. That is what we are literally surrounded by all the time. Some we can get rid of, others we really can't avoid. So those are things like your microwave. Personally, we haven't owned a microwave in probably going on 4 or 5 years now, and we don't miss it one bit. But your microwave, your toaster, if you have one that runs with infrared heating, your cell phone, and even your smoke detector, they all run with non-ionizing radiation. Your smoke detector is just the simplest device of them all. It is constantly emitting this type of non-ionizing radiation. If the room fills with smoke, the smoke cloud will block that line of emission and hence will set off the smoke detector. One other aspect that non-ionizing radiation is in our everyday lives, and that is something I personally wasn't aware of until I started looking into this, is that the CDC, the Center of Disease Control, and the AMA, the American Medical Association, have determined that using non-ionizing radiation on pretty much everything that hits our grocery shelves is the safest way for us to be protected from bacteria and parasites. So mainly that is going to be your fruits, veggies, eggs, any type of poultry meat, things like that. I'm not a huge fan of big government agencies like that, but that is currently what is going on and has been standard for several decades now. So here are the units. Like I said, just really quickly wanted to talk about them. There's several others, but these are the main ones that are used here in the United States. So those are the ones that I'm going to be limiting myself to. Gray GY here is the main unit that I've picked. It's what I'm most familiar with, but there's also RADs or REMs, and then also Sieverts. Let me go on here. So the main particles that are involved with any type of radioactive emissions are alpha, beta, and then also gamma and X-rays. So as you can see here, alpha particles are the ones that don't travel very far. They can pretty much be blocked by a simple piece of paper. Beta particles can travel a little bit further. It takes about a, somewhat thick layer of plastic to block them. But just saying that because they can't travel very far and they're easily blocked does not mean that they can't be harmful to us. If we're close enough to a source of this type of radiation, it can, in theory, penetrate our skin and still cause damage. The main ones that everybody is concerned about are gamma and X-rays. Those can travel at the speed of light. It's fairly easy for them to penetrate through skin. As you can tell, it takes a somewhat thick layer of lead to give us some protection from those X-rays and gamma rays. So let's say some incident happened, whether it was at a medical facility, it was a nuclear plant, or some type of warhead hit. In any event, you should be notified that something is going on that is not something that they're going to be able to fly under the radar. So after you've been exposed to this type of radiation, what you want to do within the first few minutes is remove all your clothing. Put it in a plastic bag and get it away from you. As soon as you can, preferably within a few minutes as well, go ahead and shower. Use soap with that, but be careful not to scrub. If you scrub, you can actually increase the amount of radiation that your body is absorbing systemically, meaning it's going to end up in your entire body, and obviously we don't want that. Hopefully you're going to be able to determine what amount of radiation you've been exposed to. I'll give you some pointers on how to determine that later. Pretty much in general, though, we can say that if it's only been a mild exposure or a mild radiation poisoning, you're more than likely going to be fine, especially if you have appropriate treatment on hand. If it's been a severe or even extreme case of exposure, more than likely, even with treatment, death is going to be following about 2 to 10 days post-exposure. One of the main problems that we run into with radiation is that our blood cells are targeted, also your organs, your skin, etc. I'll get to that in a second, but your blood cells are really going to present the biggest struggle. So just a quick overview. Blood cells, I hope you've all taken some type of biology and can remember some of it, but all of our blood cells originate from stem cells. Now, if the amount of radiation is strong enough, because that is also what we're using in a medical application, we can pretty much eradicate your entire immune cells. So the main blood cells that we're talking about, you've got your red blood cells, your erythrocytes that are, in charge of carrying the oxygen throughout your body. You've got your platelets that help you with clotting your blood. Granulocytes, there's 3 different little guys. Neutrophils are kind of like the little garbage trucks of the body. So they get a signal that something is going on. It takes them about 30 minutes to get to whatever site of infection there is in our body, and then they attack the microorganisms. They've got several different ways of doing that, but one of their main ones is phagocytosis. So they pretty much ingest the particles, kill them this way. They turn into a type of pus cell and then they die off. The second type is the eosinophils. They're the main cell involved in any type of allergen response. They also help destroy tumor cells, and they pretty much help as a mediator almost to trigger the response of other cells like B and T cells. The basophils, the last group of those, they're the least abundant ones found in the bone marrow, but they're full of histamine. So they contribute to any inflammatory response. I know everybody, or a lot of people, think that inflammation is something bad that needs to be fought immediately, but actually inflammation is one of the main messengers used in our body to help fight any type of invading organism. Then the last group of cells that we have are lymphoblasts. So we've got B, T, and then NK cells. B cells are the ones that deal with antibody-driven immunity. So, our body gets in contact with something, antibodies are formed as a sort of memory that we've dealt with this before, and then the second time around, we can attack it and deal with it much faster. T lymphocytes and natural killer cells are both also involved in the immune system, but they deal with cell-mediated immunity. So T cells are the ones that we are developing throughout our life, or the T cell mediated response is what we're developing through our lives, whereas NK cells are ones that we're born with, so they give us a natural born immune system. So the stages of radiation poisoning and also the severity, like I said, I have decided to limit myself to the gray units, but you can pick whatever makes it more comfortable for you, or whatever your instruments can read. So with any type of radiation poisoning, the advantage that we have with it is that most symptoms occur in a set order. So it's fairly easy to determine the level and also the timing of the exposure based on what you're finding in that person. So the stages, mild would be an exposure of 1 to 2 gray units, moderate 2 to 6, severe 6 to 9, extreme would be anything over 10. Pretty much all you have to remember is mild exposure. The symptoms might set in a few hours, maybe even a few days after exposure. With extreme exposure, the symptoms are going to occur within just a few minutes, maybe even less than 10 minutes. I talked about exposure levels a little bit earlier. So if you remember with the medical equipment exposure, it was 0.05 rem per year. So if you compare these here, 1 gray is the equivalent to 100 rads. A rad is the same as a rem. So it's a very minimal dosage that we're exposed to in the medical field. And so I think it helps put things into perspective a little bit, what it means when we're talking about when we're even getting hit with 1 to 2 gray units. So the symptoms, I put this little graph in here just to help demonstrate that literally everything in the body is going to be affected. Depending on the level of exposure, it could be short-term and also long-term symptoms that we're going to be dealing with. Also, we have to distinguish between the methods of exposure. So we've got irradiation versus contamination. Irradiation meaning that you're directly exposed to the radiation waves, emissions, or particles. The contamination is going to be more an issue when you're coming in contact with dust or liquid that contains radioactive particles. So if you shouldn't be familiar with it yet, this little image down below here is from a show called Jericho. You can pretty much find it on Netflix now, or also on the internet. So this is an excellent show, especially the first season of it. I recommend to pretty much everybody. And in this scenario, they're also dealing with both the first wave direct exposure to radiation, and then later on, a few days later, they're dealing with possible contamination through radioactive rain. So if you're not familiar with it yet, I encourage you to go look that up. So the symptoms that we're going to be dealing with if you're exposed to radiation, if they're very mild, you could just feel some nausea, some vomiting, you might get some diarrhea, some headaches, some fevers, very unspecific symptoms. If the exposure is a little bit more severe, you're going to be dealing with weakness, disorientation. Epistaxis is a nosebleed, overall just fatigue, because remember, depending on the exposure, all of your blood cells could have been killed off. So that is going to take an extreme toll on your immune system and on how your body and organs can function.